So now let us continue about the word buoyancy. So the word buoyant means to say to buoy up, no? To lift up. And what is the main factor that let the objects lift up? So we shall now talk about buoyant force. Okay? And what is this state of matter? No? The state of matter, which is the reason why there is a buoyancy or buoyant force. When we talk about buoyancy, it is the ability to float in a fluid. Means to say that fluid is the main component. Remember that fluids are composed of air and liquid. Okay? So these are composed of liquid and gas. No? For liquid component like water, and for gas component like air. Okay? So examples of fluids are water and air. The word buoyant force is what we call the upward force. Okay? So this is interrelated. They are connected with buoyancy. The word buoyancy, I repeat, it is a principle, the ability to float in a fluid. While when we talk about buoyant force, it is the upward force that acts on a submerged object. So there is a certain reactions, how an object acts towards its opposite gravity. So when you try to observe, okay, say for example, we have a container, then there is a brick. So of course, once you hold or carry a brick in your hand, you even feel about the weight of an object. And then, where do you think is the buoyant force? How can you see the reaction of fluid? So the weight of an object, okay, creates gravitational force, right? Downward force due to its gravity or the weight of an object. Once, if you're going to release an object, okay, it will gradually fall off without any control of other forces. However, the fluid, okay, contains pressure to let the object, okay, goes up due to its water pressure or fluid pressure under the surface. Okay, that's what we call buoyant force. So remember that buoyant force is created in a fluid component. Okay, depends on the amount of liquid present. So if the amount of liquid is huge or large, there is a massive amount of fluid, of course you have to expect that the buoyant force is high. Okay? But if the amount of object's weight is higher and then the amount of water or fluid component is less, you expect that the object continue to fall down to the bottom of the water without any pressure exerted from the fluid component. So, what is this indicator about? So, the weight of object, the bigger the force, in which, okay, this block or a brick, okay, has a bigger force, so it ended up winning. So the block will sink. So that is a possibility. So how about the buoyant force? The buoyant force of fluid could no longer hold the weight of an object once, okay, it reaches into the bottom surface of the water. So therefore, okay, what will be our indicator? By determining between the weight of an object and a buoyant force. So this time, as you have noticed in this picture, right? You observe the brake, okay, just only partially submerged. So, means to say that the water, the amount of water is equal to the weight of an object. And this is not literally the object sink or even float. However, if we go further with this one, now it's sinking, right? So the weight of an object is greater than the buoyant force. This is the reason why the object will sink. All right? So the buoyant force could no longer hold the weight of the object. That is why it continues sinking at the bottom of the fluid surface. So the indicator there is the object sink or sinking. Now, which one is easier to pick up and why? Now we will try to observe. Okay? It's easier for us to pick up with a brick. And we can put this one outside thoroughly. Then you can put it back again. Now, how about this beach ball? So why do you think this beach ball floats? Okay. So the reason there why this beach ball float, because the buoyant force is greater than the weight of the ball. Means to say that the weight of the object is less than compared to the buoyant force. That is why it enables the bottom pressure of the fluid creates its pressure to let the object goes up. Okay? So there's what we call the upward force that helps to buoy up the object since the object is light. So the weight of an object is less compared to the weight of the water. Let's move further about the Archimedes principles. What is the Archimedes principle and who was he? If you remember the word eureka, I found it. Okay? So, this Archimedes principle linked with the word buoyant force acting on a submerged object, which is equal to the weight of the fluid of the object displaces. So, if we are going to pour in a stone inside a container with water, now let's try to observe here. In this case, you will see, I'll repeat, okay? Look at the original amount of water, and then we grab the stone. Okay, so you just see the blue color at the top, right? So that one is a fluid being displaced. So the buoyant force is equal to a displaced fluid. This is a common reaction of water from its original amount of water. The water level rises. Depends on the weight of the object. So the object sink, however, it occupies the space that leads to the fluid or water component increases its level. And that's what we call displaced fluid. This is the same thing on the principle of Archimedes. He stated that the weight of the amount of water displaced is equal to the buoyant force. Alright?
Yeah.